Hi guys, if you are up to the section where you need to draw some graphs of your exponential functions, then I'm going to go through how you go about doing that. So just a reminder, on your CAS calculator you want to go to this button here, the one with the little picture of the house. That will get you to your home screen. Do not use Scratchpad. Use one of these down here. So I'm going to open up both the calculator page and I'm going to go back to home, and I'm also going to open up a graphing calculator page. In my graph, I'm not going to change the name of this to N or T or anything else. I'm going to leave it. And over here, I'm not going to use variables like D or T or anything. I'll just use X. But apart from that, you enter the equations pretty much as they're shown. So if you had an equation like 30 times 10 to the power of, you can go directly to that, or you can type in 10 and then use the your hat button. 10 to the power of, and then it might be 0.4 times, your equation might say t or something, but like I said, I'm just going to use the variable x. Once I've typed in the equation exactly as it appears, except that I've replaced that variable with the name x, then I can press enter. Now if I'm lucky, I'll be able to see the graph on the page. If I'm not lucky, then maybe the graph will be there, but it will be off the scales that are set. So the next thing I need to do is make sure that these scales are reading the right values. There's two ways to do it. I can go to menu. Clunky ways to use zoom out and things like that. Or I can go to window settings and I can change the values of the x-axis by changing these two, and I can change the y values there. So if I change y max, for example, to let's change that to say 100, I'll get a very different look at the graph. And now you can see 100's appeared there. The short way to do it is I can change these values directly by just going to them on my screen, double clicking on it, and then changing it to whatever it is that I want them to be. If you're not sure what you want them to be, your tables are a really good kind of clue to that. Have a look through the values that are appearing in your tables. But if you're really stuck, you can go to menu zoom out until you can see a picture of the graph, and then just have a look at the kind of values that make sense. Negative time doesn't make much sense, so we're not really going to need much of the axis here. And depending how far your values go, it's going to depend what two values you enter there. Alright, let's say that I've got a second graph. So I hit my tab button to enter a new graph. That gives me my command line. And my next graph might be something like this. 20 times 9 to the power of 0.2 times x. Let's say that that's the value. So I've got my second graph. One graph, two graphs. And you can see somewhere over here they're crossing. If I want to figure out exactly where they cross, then I can use Analyze Graph. Menu, Analyze Graph, and the one to find where they cross or intersect would be intersection. And you can see a little picture of what that's going to look for. It asks for a lower bound. I have to click somewhere to the left. Upper bound, somewhere to the right, and that grey area is the area they're searching, and so I get the intersection point. If I wanted another equation, another point of interest, like for example the y-axis. I can also use analyze graph in another way. I can use trace, graph trace, and by hitting my left and right arrows, it'll eventually get to a spot where a little tag says y-intercept, and by pressing enter, it'll stamp that point onto the axis. And all this is shown to you in the other video as well. But let's have a look at other ways that I can do things. Let's say I've got an equation that looks something like this. D equals n times 10 to the power of 0.05 times t. Alright, now if I was entering that on the graph page, I might say function number 1x, and I might put an x in place of that. But what about this n here? In part C, it asks you to find one of those n values. It tells you something like this, that when d equals 100, t's value is equal to 5, something like that. So if we wanted to figure that out, then what I can use is menu algebra and solve. I'm trying to solve an equation. Solve is what's going to do it. So let me show you how you can do that. I use the solve command. I open a bracket. And then what I have to do is put a comma and tell it what I wanted to find the value of. I wanted to find the value of n. This bit here I can include by using my AND statement. Need a space. And when I press that, it now tells me what the value of n would have to be when t was 5 and d was 100. Now I know that my equation has changed. This n is a constant value, so it's always going to be that value. So if it then asks me how many dogs there were after, say, a time of 10 years, I can now go ahead and figure that out. It will be D equals I just go up and I have to get rid of those. That's my n. Then it's times 10 to the power of 0.5 times, and I said it was after 10 years. So after 10 years, the t value would become a 10. So this one here, I've used a point to find this constant value of n. Now I've found that value. That's going to be the value in every single different equation where I have to find a d from now on. And that'll tell me there'd be 177 or 178 dogs after 10 years for that particular equation. Once I've done that, I can use it for whatever other values I might need to find. After 20 years, there'd be 562 dogs, and so on. If I wanted to figure out the t-value, like how much time would pass before I'd get to 200 dogs, I can use my solve again. Menu, algebra, solve. So the dogs is the 200 value. And then I go up here, enter. And it's the t that I'm trying to find out. So it's comma t. So this time I'll replace the d value with 200. I've got my constant that I found up the top, times 10 to the power of 0.05 times t, and I want to find out what t value makes that true. So press enter. It tells me it would take 11.02 years, so just a bit over 11 years to get to 200 dogs in the park. Okay, so I hope that kind of shows you about the graphing and the solving part of the equation.